Imagine looking at a night sky full of stars. Each star is a piece of data. Now, imagine wanting to group those stars. You might group them by color or brightness. That's what support vector machines or SVMs do with data. SVMs are like powerful telescopes for your data. They help us find patterns and make predictions. They are essential for scientists, analysts, and anyone working with complex information. SVMs are like detectives of the data world. They sift through mountains of information. They identify the most important features. This helps us understand the relationships within the data. Whether you are mapping the human genome or predicting stock prices, SVMs can be incredibly useful. One of the key things SVMs do is classification. Imagine you have a basket of fruit. You want to separate the apples from the oranges. An SVM can do this with data. It learns the characteristics of each fruit type. Then it can classify new fruits based on those characteristics. SVMs are used in many areas that require classification. For example, they can help identify spam emails. They can also help doctors diagnose diseases based on medical images. By recognizing patterns, SVMs help us categorize information effectively. SVMs are also good at predicting future trends. This is called regression. Imagine you are tracking the growth of a plant. You measure its height every day. An SVM can use this data to predict how tall the plant will be in a week. This ability to predict the future is invaluable in fields like finance. SVMs can help predict stock prices or analyze market trends. They can also be used to forecast weather patterns or estimate crop yields. By understanding past data, SVMs can make educated guesses about the future. How do SVMs actually work? Imagine drawing a line to separate your apples from your oranges. That line is called a hyperplane. SVMs find the best hyperplane to divide your data. The goal is to create the biggest separation between the groups. In reality, data is often more complex than just apples and oranges. Instead of a simple line, we might need a multi-dimensional hyperplane. It's like separating different colored marbles scattered in a three-dimensional space. SVMs excel at finding these complex dividing lines. Section 5. The guardians of separation support vectors. Not all data points are created equal. Some points are closer to the hyperplane. These crucial data points are called support vectors. They are like the guardians of the separation. They define the boundaries between the groups. These support vectors are essential. They are the key to the SVM's accuracy. By focusing on these critical data points, SVMs can create robust and reliable models. They ensure that the classification or regression is based on the most important information. Section 6. The kernel trick, unlocking hidden patterns. Sometimes data is not easily separable with a straight line. The data points might be scattered in a way that makes it difficult to draw a clear boundary. This is where the kernel trick comes in. The kernel trick is like giving the SVM special glasses. These glasses allow the SVM to see the data in a higher dimension. Imagine lifting your scattered marbles from a flat surface into a three-dimensional space. Suddenly, it might be easier to separate them. That's what the kernel trick does. It finds hidden patterns that were not visible before. Section 7. SVMs in action real-world applications. SVMs are used in countless applications today. They are helping doctors diagnose cancer earlier and more accurately. They are used in facial recognition software and fingerprint analysis. They even power the recommendation algorithms used by companies like Netflix and Amazon. In the field of astronomy, SVMs are used to classify galaxies and stars. They can even help identify new celestial objects by analyzing telescope data. The versatility and power of SVMs make them an indispensable tool in many different fields. Section 8. Advantages and limitations of SVMs. SVMs have many advantages. They are very effective in high-dimensional spaces, meaning they can handle datasets with many features. They are also memory efficient because they only need to store the support vectors, not the entire dataset. However, SVMs also have limitations. They can be computationally expensive to train, especially on large datasets. They are also sensitive to the choice of kernel and hyperparameters, which can require some expertise to tune properly. Section 9. The future of SVMs. As we continue to generate more and more data, the need for powerful machine learning techniques like SVMs will only increase. Researchers are constantly working on improving SVMs, making them faster, more efficient, and applicable to even more complex problems. From personalized medicine to self-driving cars, the future of SVMs is bright. As we venture further into the age of artificial intelligence, SVMs will undoubtedly play a critical role in shaping our world.